All right, welcome everyone to another edition of On-Prem Pros. I'm your host, Ryan Brown, and with me, as always, my two partners in crime, Mr. Josh Moss and Tyler Young, solution architects from Xbyte Technologies. Welcome, gentlemen.
Thank you. Thank you.
Good morning.
Welcome. And today, we're here to talk about hardware RAID versus NVMe Direct. So as solution architects for Xbyte Technologies, they're asked a lot about, okay, hey, which one should I get? Or we have a lot of customers who come to us and say, hey, I always want hardware RAID. And so what we did, we said, okay, why is that? Why is everyone coming to us and saying, I always want hardware RAID? So before we get into some of the testing that we did to kind of figure out, really, is it better? Josh, Tyler, can you talk to us for a second about why do customers assume that hardware RAID is better, or why is that their default selection?
Yeah, I think a lot of what it is probably just going to be familiarity. A lot of these customers are coming from, older generations of Dell servers that, they might have used SAS SATA disks, and they're just, more familiar with creating a virtual disk and presenting it to the OS. So I think a lot of it is probably just going to be assumptions and, familiarity with what they already know.
Yeah, and to add on to that too, if you think about, when you go back to just normal SAS SATA hardware RAID controllers, those are typically more expensive than doing software RAID, right, on servers, whether you're talking about Dell or any other server manufacturer. So, I mean, just again, if they carry on just what they've always done, again, it's just something that they're going to assume that the actual physical controller is going to just be, better.
Are there any actual limitations with compatibility? So are there any major OSs or virtualization platforms out there that can't support one of the two?
Yeah. VMware is one of the main hitters that cannot support quote unquote software RAID. The only exception is if they're doing any, sort of architecture like vSAN, right? That's, vSAN ready nodes, VxRail, et cetera, right? That's different, right? Uses that software magic. But yeah, just in general, VMware doesn't support software RAID. But I mean, outside of that, I mean, Windows can, Linux flavors can do that. I mean, it's pretty common for most hypervisors.
Okay, that makes sense. All right, so guys, let me go ahead and bring in our test results, and I'll let Josh kind of set up what we did to test, because we said, hey, we want to see, really, as we said, is hardware RAID really better or more performant than the NVMe Direct, or what we call software RAID?
Yeah, so we have two Dell PowerEdge R7615s. That is a single socket AMD build. The particular chassis in question, they're both 8 by 2.5 inch NVMe. One of them does have an PERC H755N hardware RAID controller. The other was NVMe Direct. A single proc, 384 gigs of memory, and then 960 gig Gen 4 NVMe's. And both tests were conducted running Ubuntu as well. One thing I do want to note is that the tests in question, they were done so on the raw devices themselves. The goal here was just kind of, benchmark, with removing any and all factors that we possibly could, namely file systems here, just benchmarking the raw devices themselves.
So let's get into the first test here. So on the first test, we wanted to, the setup of this is we wanted to kind of, the first couple tests, I should say, we wanted to look at different databases and different random read writes and how did they perform. So Josh, you kind of walk through the results here, and surprising results, I should say.
Yeah, so we've got three columns here, and I'll just quickly explain why. So the first column, you see NVMe Direct. That's utilizing MD RAID and Ubuntu. And then the second two columns that we have here are both with PERC H755N managed virtual disks. Again, RAID 10 in both situations. But what we did is we tweaked the controller caching policy. So that middle column, you'll see where it says read ahead, write back. That's utilizing the controller cache. And for this use case, since it's not HDDs, read ahead really doesn't matter in either case. What really matters is write back. And then the last one is write through. So what write back is, what happens as soon as the data hits the controller and it's finished with the transaction, the controller will acknowledge the write and the host will just continue on, and then it'll continue on the back end and flush the data that is in cache to the disk. What write through does is it just effectively it bypasses the controller cache and just IO is issued from the host OS directly to the disks. And what we see here is that by doing so, you actually get much more performance compared to the default standard out of the box settings whenever you do create a PERC virtual disk. But from here, just kind of going left to right. So read IOPS 398,000. We got about 1.6 gigabytes. Write IOPS 171 with a total about 569. You can see with the out of the box settings that are default with read ahead, write back. The NVMe Direct software RAID just completely blows it out of the water. But what you see kind of interesting in the last column there is that whenever we're allowing the host to just ignore the cache, we're getting, it's still not as good as the NVMe Direct software RAID, but it closes that gap quite a bit with a total of 433,000 IOPS. But overall, the software RAID NVMe Direct chassis does still outperform it there.
Yeah, and I do want to jump in for a second, and I think this is something that a lot of our viewers are definitely kind of just really appreciate, and is a really good testament to you specifically, Josh, but also just our professional services at Xbyte is, and correct me if I'm wrong, but the default configuration from Dell is that middle column, the NVMe hardware RAID, or I'm sorry, with NVMe hardware RAID, that default configuration is the read ahead, write back configuration. So you actually went in and looked at the different configuration options that you can do within Lifecycle Controller, and you tweaked that controller to change it to the no read ahead, write through configuration, which then what nearly tripled, quadrupled the overall IOP. So again, that just goes to show that you know, just because you purchase the hardware and you have the hardware in place doesn't mean that it's the best configuration for your workload. But at the same time, too, right? That just shows that again, we know what we're doing, and we can really come in there and make sure that we're fine tuning and optimizing the hardware that you have in place for your specific workload. So, yeah, just kudos to you there.
Yeah, yeah, and it's simple to just go through the process, click next, next, next. You kind of assume that the defaults are going to be typically what you want, but this definitely shows that's not necessarily always the case.
I'm going to jump to the next slide. And this is interesting. So this one, we took the same concept. We want to show database workloads, but we changed the block size. So instead of 4K, we went to 64K. And we want to just kind of show a difference between that. And so with that block size, we also saw a difference in performance. And it looks like it almost leveled it off. The NVMe Direct is still maybe 10, 20% ahead on performance, but we definitely see that gap closed. So Josh, can you explain a little bit about what you saw here?
Yeah. So again, out of the box settings here, the NVMe Direct did outperform the hardware RAID. But then again, once we changed the read ahead and write through caching policies, which by the way, you can do that at any point in time after the virtual disk is created. You don't have to go through and delete everything and reconfigure it. But after having done so, we actually see that the NVMe hardware RAID, it does outperform the NVMe Direct software RAID configuration with this particular IO. And again, this is just kind of what, based on what Tyler and I see a lot of the times. 70/30 is a pretty good read write ratio. The block size, it does absolutely vary depending on, from customer to customer, from workload to workload even. So these are just kind of baseline numbers, based on what we see, most of the time.
Now, Josh, a question on this one. So when I'm looking at these columns and I see the write through cache helping, and kind of contrary to its name, the write through cache is helping the read performance more than it is the write performance.
Mhm.
When I'm looking at this, can you? I'm looking at this. Maybe I'm lying. Nope, I'm lying. See, this is why we do these live. As I'm looking at this, I'm like, oh, actually, no, it did boost both of them. So yeah, so and why is that? Why does that cache then affect if really the driver is that write through piece of it? How does that benefit both columns
Yeah, I mean, simply
or both
stated,
rows?
in NVMe it's low latency, high throughput. Whenever you put the controller cache in there, again, depending on the workloads, it can actually hinder the performance a little bit. But yeah, that's just because the throughput and the performance capabilities that the NVMe's possess.
And just to add on to that too, I think another thing to kind of keep in mind that read performance boost maybe because it's no longer that you have it set to the no read ahead versus having it set to the read ahead, right? Where the no read ahead is boosting that read performance, and the write through is mainly helping out on the write performance. So again, that very well could be as well.
Very interesting. So the last test we're gonna share here. Actually, no, we have two tests we want to get into here. So the first one is we talked about some database workloads. Now here's a streaming. So this is someone where they have some sort of file server out there. They have videos or they have some kind of large files, and they're streaming it out there to the. So this is 1 meg sequential reads. So Josh, can you talk to us about these results?
Yeah, so like Ryan alluded to, the 1 meg sequential read is going to be characteristic of streaming service, like just streaming large files across the network, or just any large block read operation. So here we see that across the board, and generally speaking, we'll see kind of when it comes to the software RAID with MD RAID, it excels within read IOPS very well. So here we can actually see something interesting. No matter what we configured, from a storage controller caching policy standpoint, we actually got identical results across the two NVMe hardware RAID options that we got with the 14.4 thousand IOPS compared to the nearly 45,000 IOPS on the software RAID. And you can see that reflected in the number of IOPS overall, and also how many gigabytes a second that we're doing as well.
And a little
Yeah.
side note here too is when we're talking about these, any sequential workloads really, but especially when we're talking about anything that has to do with like that, the large media streaming, whether it's large files, videos, backup processes, etc. Yes, IOPS are still obviously important, but I do know that a lot of times those workloads benefit more from that back end throughput. The back end through just the back end disk throughput being higher versus having better IOPS. But again, nonetheless, obviously the NVMe Direct is obviously severely outperforming on both those metrics. But keep that in mind is that again, the sequential workloads are definitely leveling those back end throughputs a lot more too.
Now, Josh, why didn't we see a boost? So before on the last two slides, we talked about the last two workloads. We talked about how with tweaking we saw increases in our IOPS on the last column here. So why did that one not impact us on when we moved up the block size to 1 meg?
Yeah, simply stated, I think we're just, we're bottlenecking the PERT controller itself. That's the only difference between the two configurations, is going through that PERT. So again, this is a H755N. There are newer generations. Once we can get our hands on them, I am interested to see how they perform. But yeah, simply put, the PERT controller as the bottleneck.
And interesting is we've done testing before on SSDs to kind of show at what point do we saturate the RAID controller, and there's no benefit to the IOPS. So a lot of people think, okay, more drives equals more IOPS, but at a certain point, kind of like this, you're saturating that RAID controller, and you're no longer seeing those benefits.
Yep. And one thing, kind of along the same lines of, not all out of the box settings are always good. These were created with the default stripe width of 256K on the perk. That is, whenever you create the virtual disk, it's definitely recommended to also align that with as close to whatever you expect the workload to be in terms of block size. And that to change that, unlike changing the caching policy, it is a destructive process. You do have to remove and recreate the virtual disk. So I definitely recommend choosing that correctly out of the gate.
All right, so now let me go ahead and go to our last one here. And this is going to be backups. So we're doing large backups, so 1 meg sequential writes. And so this is one where so in the beginning we sought to think, okay, hey, where do we actually see hardware RAID outperforming NVMe? And it turns out in most of our workloads, we actually saw the reverse. NVMe Direct did outperform our hardware RAID. It's starting to get a little bit closer in some occasions, but in general, it did outperform. But in this case, we're seeing the opposite. This is where the hardware RAID is going to make the most sense is on backups. So Josh, can you talk about this a little bit?
Yeah, so as Ryan alluded to, the inverse is true on this whenever we come to compare the caching policy. Whenever it's default settings, we actually get that 9.5 gigabytes a second and 9,000 IOPS compared to right through you get lesser IOPS, and then compared to the software RAID at a kind of a baseline, it's more in line with the no read ahead and write through policy. So like you mentioned, this is definitely a good use case for something like backups as well.
And a good example of, as Tyler talked about before, about why you want to have someone help you tweak your settings or to kind of do testing. Because in this case, the workload, while you may have looked at our first two examples or first few examples and said, okay, hey, I always want to set no read ahead and write through. But in this case, it hurts you. So you'd want to do the reverse of it. So definitely think through those, any of your settings, or seek someone who kind of does this a lot to be able to assist with that. All right, I'm going to go ahead and we've gone through a lot of these. And before we sign off here, Tyler, we're going to go to your favorite topic. So we talked about a lot of workloads here and different block sizes and what that does to performance. How do customers, if they're not 100% sure where they fall in any of this, and if maybe they don't have the technology or whatever to be able to kind of create these settings, how do they kind of test where they are right now?
Yeah, no, that's a great point. And just full transparency to you guys. I mean, most customers we talk to don't truly know their exact IO size or the read write ratio, and that's okay, right? There's tools for that make things easier for everyone. And that one of those is, I think we talked about in the past, is Live Optics, right? It's Dell's tool. So you just run that against your infrastructure, and what it does is it'll give us just an idea of not only the performance metrics, IOPS, disk throughput, etc., latency, but it also let us know what your read write ratio is on average, what your IO size is for that workload. And what we can do is we can then look at those and not only assess what the best optimization and fine tuning is for your your deployments, but also if you're looking at any sort of higher end storage array, right? We can also predict what kind of performance output you're going to be receiving from those those solutions. So again, great tool, free. Not trying to sell you guys anything else. And like I said, it's very easy to use. So easy I can use
it. And one of the things I love to talk to customers about is using that as your report card. So you run it first, and then you before you do any kind of hardware upgrades, and then run it afterwards to be able to kind of show your boss, hey boss, look, I was so smart. I went to Xbyte. They recommended this hardware configuration, and now our performance is even better. And kind of show that, and then even to use that periodically to kind of test, to say, okay, hey, is anything changing with our workloads I should be aware of that may need to tweak something? And so it's good to kind of do those every quarter, I would say, to kind of run it and to kind of check yourself where you are, and you may get some surprises in there, and that'll help you kind of stay ahead of that by being able to kind of track some of that.
Yeah, and just one thing to kind of add on to is once we know what your, requirements are, right? What kind of IOPS you need, your throughput, etc., right? That's something where then we can even look at the different results that say the maximum performance that a hardware RAID solution can do for your workload, or maximum performance output that a software RAID solution can do for based on your workload profile. Just because obviously we want to make sure we're giving you guys a solution that's maximizing the performance, but maybe you don't necessarily need that for your workload, right? So maybe if say one solution that's going to give you the the better maximum performance, maybe that costs more money, and maybe yes, that'd be great to have, but maybe your requirements are half that maybe the lesser the solution can meet. So again, just understanding that will just also show us what those options are available to you guys, and again, just helps us out along the way.
All right, Tyler, thank you very much. Josh, thank you for all that amazing testing and the explanations of kind of where everything's sat. And everyone, thank you for listening, and hopefully this has been enlightening, so you can look at your workloads to figure out, okay, really, maybe I was looking at hardware RAID, but I should look at NVMe Direct, because there's a lot of benefits to that. So Josh, Tyler, thank you guys very much. This is Ryan Brown signing off for On-Prem Pros.
Thanks, everyone.
Thanks.